Hello, this is Chelsea Oliver recording my interactive whiteboard session using bContext. So today I chose to look at some data from the 2012 London Olympics, looking at the women's 400 meter hurdle event, and this was a semi-final event. The reason I used a semi-final event was so I would have a good enough sample size, which is n equals 24, which you can see is right up here in the top corner. And then it's also right over here where all this data is listed. 24 data points were used. So the sample size was 24, which is a pretty good sample size. Anything above 20 we like to work with. And so after looking at this data and thinking about what plot I could use, I didn't really want to use a dot plot because the points are just so precise that I don't think a dot plot would really help me see anything. So then I was down to the box plot and the histogram. Both of them would show me the trends pretty well and to see if there's any skew or anything like that. The box plot would have done a really good job at showing the 5-number summary, but I started looking into the histogram and I just really liked how it showed the movement of runners to see when they were crossing the line in relation to other runners and the times. So that being said, I'm going to teach you how to create a histogram today. To create the histogram, first you need to create your axes. So there are 2 axes that you will use. So we'll just create that to begin with. So we have our y-axis. Do this as straight as possible. And then we have our x. So there's that. And then I want to create my points for this. So I needed to figure out how many intervals I wanted to use, and I decided that I would do 5. So that being said, in order to do 5 intervals, you need to figure out how much needs to represent each one. So I found the range, and to find the range, you take your maximum value, 56.71, and you subtract it from your minimum value, 53.33, and I got a range of 3.38. So then what I did is I divided that by 5 and I got 0.676. So that's what each of the intervals will represent, is 0.676. So now breaking this back up, we'll just get a marker back. We'll start at 53, go by 53.5, 54, 4.5, 5, 56, 56.5, 57. Let's see if we can label this. So we have 53, 53.5, 54, Oop. Let's get that out of there, 55, 55.5, getting low on room, 6.5. We wanted to go out to 57, so I'm just going to need to extend this once more, and this will be 57 out here. And then up this way, we're going to go by 2s. So 2, 4, 6, 8. So I don't have a lot of room to show my axes, but that being said, we can still find some room for it, so we'll do it in a different color. So this is the number of runners. And then, so that's our y-axis, and then our x-axis, I'm just going to put this over here. Even though it would usually go under, would be the time, and that's going to be in seconds. All right, and then we'll title this, let's see, semi-final 400 meter women's hurdle. All right, so now it's time to break it up. So when I found all my intervals, like I said, it's going to be 0.676 for each interval. So starting with 53.33, we're going to go to 54.006. So that's right past the 54. And if we look at our data, if we are going to 54.006, we only have two values in between that. So 54.006. Starting at 53.33, just have our two data points. Okay, and then next we're going from 54.006 to 54.682. So that was, let's see, 1, 2, 3, 4. So we have 4 data points between those two. So 54.682. 4 data points. There's another one. And this is again as precise as it can be. And then our next, let's see, 54.682 to 55.358. So 1, 2, 3, 4, 5 between those two. So 55.358. A little bit past halfway. We have 5 points. There's that one. And then our next one, 55.358 to 56.034. So let's see, 55.358. 1, 2, 3, 4, 5. Looks like we have 5 points. Again, let's just double check that. So we're going between 55.358 right here to 56.034. 1, 2, 3, 4, 5, 6. Oh, 6 points. Okay. So 56 right past there. Oopsie. We'll delete that and do that again. That doesn't look very good. 56.034 to 6. Alright, there's that one. Then our final one goes from 56.034 to 56.71, and 56.71 is our maximum value. So let's see, we have, how many points do we have left? 1, 2, 3, 4, 5, 6, 7 points left. So 56.71 right before the halfway point, all the way up to 7, and then cross it back over here. So here is our histogram for this set of data. So just talking a little bit about the histogram, as you can see, it really shows the distribution of runners, how we just have a small amount coming in at the beginning with each interval, and then by the end, that's where the cluster seems to fall. So if we look at this and we look at our data up in this box, let's see, up here. So not all of this is important. We already talked about how n, which is the sample size, equals 24. So our mean is 55.3379. And our mean is the average. So when we add all of our times up and divide by our sample size, that is the average time of the runners. And then our medium is 55.605, and that's just the middle value. So as you can see, the median is slightly higher than the mean, and so this means that we, well, it means a couple things. It means first that we have a negative skew, and you can see this because the data, if you look at it, it's going in that downward, that negative slope. So we have the negative skew, and this also means when the mean is less than median, it means that we have some smaller values, which we can look up here, that pulls the mean down this way. So that is why the mean is slightly smaller than the median. Other than that, this is basically all you need to know to create a histogram. So a histogram is great at showing the data distribution, and that is what I wanted to show with this semifinal hurdle in the 2012 Olympics.